Hello and welcome back to this multi-part series in statistics. We have a party going on here. So let's begin. This is presentation 7.3 and the topic is confidence intervals and sample sizes. Now this illustrative problem we encountered in the last lesson, and you see the information coming on the screen here. This is basically the central limit theorem that from a population with sigma sub x equals 9.0, we have a 95% region about the mean, within which 95% of the x's will fall. Now if we look at samples of size 36, we see that these will cluster about the population mean, which we don't know. The standard deviation, called the standard error, is given by sigma over square root of n, and that means, of course, that the 68% region, of course, is plus or minus 1.5, and the confidence interval, or 98% region about the population mean, within which 95% of the x bars will fall, is given by this information here, plus or minus 2.94. It's called the margin of error. It tells you how close we are to the population mean with 95% reliability. Now we're going to look at this problem at hand. This is the same problem as before. We want to look at the margin of error. The margin of error is 1.96 times the standard error. That's the 95% margin of error. That's given by 2.94, and we see it coming on the screen here. And that is the symmetric region above the mean. Now we're going to look at the sample means themselves. You see them coming on the screen here. 95%, or 19 out of 20 of these x bars, designated here with the red dots, falls between these two red lines. One on average will fall outside. And now we're going to look at these intervals. We simply take that margin of error here and add and subtract it to each of those means, and we get these intervals, and these are called confidence intervals. Now you'll note that 95% of these intervals will capture the true population mean, which we still don't know. One on average will not, and that's this one here. And therefore, if we knew an x bar, 67.8 pounds, the confidence interval estimate becomes, in this case, 7.8 plus or minus 1.96 times 9 over square root of 36. And that gives us this confidence interval. And 95% of all such confidence intervals will capture the true population mean. And this information we suggest, as a result of our conclusions above, we can conclude that the birth weight has dropped significantly below 74.8. The general formula for confidence interval is your estimate plus or minus your margin of error. Now we're going to look at another illustration, and pause the screen at any time to take notes. We have here the mean weights of men in an elevator. We don't know what the mean is. We do know that sigma is around 25.2 pounds, and this allows us to calculate the standard error, 3.94. It's coming on the screen here. It's called the standard error in our estimate, and that's your 95% region about the population mean, which we don't know, within which 95% of the x bars will fall. Now we're going to look at a margin of error, which is your z-score, 1.96 times your standard error, 7.71. So we're 95% certain that we're within 7.71 units of the population mean. Now if we find that x bar is 173.4 pounds, we simply take that estimate and add and subtract your margin of error, and we come up with this interval, which is your confidence interval. And that is effectively a dot somewhere here, and this interval, there's 95% chance this interval will capture that true population mean. If the elevator claims were based on a mean weight of 160, then we should change the contents of the signs to a lower limit. Now we're going to look at the sample sizes. Suppose now, under the scenario above, we wish to find an estimate of the true mean, of the mean weight within 4 pounds with 99% confidence. And you can see here it's all based on that error term, 99% chance, 2.7575. Sigma over square root of n, that's plus or minus 4. If you cross multiply, we get this expression. And if we square, we give n equal to 264. And note that sample size controls the tightness of these, the standard deviation in these sample means. And that's the end of presentation 7.3. We ask you to take notes as required and go to 7.4.